How many different computer passwords are possible? So if you have 3 numbers followed by 4 letters. So first of all, how many numbers do we have? If you count from 0 to 9, how many numbers would that be? 10. So there are 10 options for every number. 10 choices. And then followed by 4 letters, or letters, we can go from A to Z. That's 26 choices. So that's important to keep in mind. Oh, I'm sorry. I'm not showing it up there. Oh, I'm so sorry. All right, so 0 to 9, 10 choices. A through Z, 26 choices. So if I have 3 numbers followed by 4 letters, how many different computer passwords can I create? So the first 3 are numbers. Let's draw 3 lines. And on every line, we have 10 choices. And it's followed by how many letters? 4 letters. So 4 letters and 3 numbers. So I'm going to draw 4 blanks. 2, 3, 4. And how many letters do we have in the alphabet? 26. So pick up your calculators and you're multiplying all 7 numbers. So it's going to be a pretty big number that you're going to get. Can you put that away for me, your phone? Thank you. So in your calculators, take 10 times 10 times 10 times 26 times 26 times 26 times 26. I'm going to do that with you because this is a big number. And you should get, ooh, that's a big number. Okay, so I got 4, 5, 6, 9, 7, 6, 0, 0, 0. I don't know who I hear. Is that yours, Alan? Something is extra loud. It's a little disrespectful. I'm used to disrespectful kids, but if y'all could please put it away, I appreciate it. Just for the next few minutes, and then y'all can go back to whatever y'all doing. Okay. So it has to be, so now we're going to add a rule. And this is really important because you're going to see this on the test, is it cannot be repeated. So I'm going to continue with the same format. Go ahead and draw 3 dashes. But now we can't repeat. So whenever you add that restriction that it cannot repeat, that just means we have to count backwards. So for my first 3 digits, instead of 10 times 10 times 10, it would be 10 times 9 times 8. Because now we cannot repeat. And then for my 4 letters, 1, 2, 3, 4. I'm going to start at 26, but I'm going to count backwards. So 26, what would be the next number? 25, 24, and 23. Go ahead and multiply this in your calculator and see what you get. All right, and that would be your answers. Any questions about our bell work? Your test is actually next Tuesday, and then we'll start working on our final. So let's flip ahead in our packet, and now we're going to talk about compound probability. So for compound probability, go to page 12 in your packets. That just simply means that we want to know the probability that two things happen. So what if you had a coin flipped and you would roll a die, or you would pick a marble out of a jar? How would you calculate the probabilities of multiple events occurring? And what you're going to do is just multiply the probabilities. That is how we do that is what we do when it is a compound probability. So I have more than one thing happening, and I want to know the probability that they would both happen at the same time. We're going to multiply them together. So we would multiply them together. So for this first one, and we're on page 12, it says, what is the probability that a coin, so you got two different things happening. We got a coin that shows tails, and we have a die that's on a 3. So let's start off with probability of tails. What's the probability that a coin lands on tails? So let's start off with that one. I'm going to write that one in purple. So probability of tails. What's the probability that you flip a penny and it lands with the tail side up? 1/2, right? A coin has two sides, and one side is tails, so the probability of tails is 1/2. And now let's think about a die. What's the probability that you roll a die? A die has 6 sides. How many of those sides have the number 3 on it? 1. So if I want to know the probability that these would both happen at the same time, I would multiply these together. I'm going to multiply these two. So the probability, and I'm going to put a T for tails, tails and a number 3. We're going to actually take 1/2 times 1/6. 1 times 1 is 1, and 2 times 6 is 12. So this is your answer. And what did we have to do to get that? We just had to multiply. So let's look at question 3. Or B, sorry, question B. Probability that it lands on heads. So probability of heads. A coin has 2 sides. Only one has the heads on it, so 1/2. And on a die, how many of the numbers are odd? So on the die, we have 1, 2, 3, 4, 5, 6. Do you all know the difference between an odd number and an even number? All right, so how many of these numbers are odd? Yeah, 1. What else is odd? 3. What else is odd? 5. So how many numbers did I just circle in red? 3. So the probability of an odd would be 3 out of 6. So now let's go ahead to find both probability of heads and odd. Well, we're going to multiply these two together. Go ahead and multiply it. 1/2 times 3/6. So 1 times 3 is 3, and 2 times 6 is 12. And you do not even need to reduce that. 3 out of 12, we done. So the probability that you get a coin that lands on heads 5 times in a row would be 1/2 multiply it 5 times. Because every time you flip a coin, the probability is 1/2. So the probability that it would land on heads every time would be 1/2 times 1/2 times 1/2 times 1/2 times 1/2. So in your calculator, if you were to multiply 1 times 1 times 1 times 1 times 1, you still get 1. And then go ahead with your calculator, figure out what 2 times 2 times 2 times 2 times 2 would be. Or you could simplify that and just put 2 to the power of 5 if you know how to do that. But if you don't know how, just multiply it 2 times 2 times 2 times 2 times 2. Can somebody close my door for me? I appreciate it. Thank you. So I think that's, what did you all get? What is 2 times 2 times 2 times 2 times 2? 32. All right, so let's go ahead and go to our next page. I think we're on the next page. And then we're going to do 3, 4, and 5 and in there. So we got a jar. The amount of people that thought they had to multiply these numbers, I'm not really sure why you would have to multiply these numbers to figure out how many marbles are in the jar. But let's start off by doing that. How many marbles do we have in the jar? If I have 5 blue, 2 purple, and 6 green, what should you do with these 3 numbers? Add them. So what is 5 plus 2 plus 6? 14. I heard somebody say 14. I don't think it's 14. What did you get? 13. Anybody get 13? Okay, so 13. So what's the probability that you get a blue the first time and then a green the second time if I put it back? So with replacement means that my denominator does not change. So we said we had, how many marbles did we say we had? 13. So what 2 colors did they say? They said the first time we pulled a blue. So let's start off with that. How many blue do we have out of 13? 5. So we got 5 out of 13. Multiply, and then the second time, see how it says denominator stays the same? So I'm going to put a 13 at the bottom, keep that the same. The second time we pulled a green. How many green do we have? 6. So pick up your calculator. Take 5 times 6, and then 13 times 13, and that's your probability. And I'm not doing this with a calculator because I'm trying to wake my brain up. And I'm pretty sure that's the answer you got. Who agrees with my answer? Who got that? All right, so now it says without replacement. So that means that my denominator is going down. Denominator counts down because I'm not putting it back. So that means I'm not going to have 13 anymore. The first time I pulled a marble, the probability is still going to be 5 out of 13 that is blue. But if I don't put that marble that I took out back in, now I have 12. I don't have 13 because I didn't put it back. So when I reached into the jar the second time, it was only 12. So go ahead. Notice that the numerator is still 30, but your denominator is going to change. So go ahead and take 13 times 12. And you should get 156. All right, couple more questions and then we're done for today. The probability that it rains on Monday is 0.1. The probability that it rains on Tuesday is 0.8. What is the probability that it rains both? That means I have to multiply. So I have to multiply the probability of rain on Monday times Tuesday. So you're going to pick up your calculator. You're going to take 0.1 times 0.8 to get the probability that it rains both days. All right, so now we're going to do this table here, probability. So this is a table based off of a story that was in our old textbook. So in this town, 40.49% are males, 75 or 0.75 are white, and 0.13 are left-handed. So let's figure out the probability that they are male and left-handed. Probability of male and left-handed, because of this word and, that means I'm multiplying. My little pen is so raggedy, but I'm trying to hold on and not buy a new one. So you're going to figure out the probability of male and left-handed. Male is 0.49. Left-handed is 0.13. Multiply those together. Pick up your calculators, type it in. And you should get, I'm going to write it in red, 0.0637. So to find the probability that a person is male, left-handed, and white, that means I have to multiply all three of these together. So we're going to multiply 0.49 times 0.75 times 0.13. Go ahead, pick up your calculators. So this is not given to you in the table, but can you add that the probability of female is 0.51? That's the probability of female. So to find the probability of being female and left-handed, you're going to multiply 0.51, because that's the probability of female, times left-handed, which is 0.13. And that's it. So we're going to continue with this tomorrow. Tomorrow we're going to start conditional probability. You can start working on, I saw a lot of people already submitted homeworks 1 and 2. Those grades have been put into Skyward. You can do those more than once if you're trying to get a perfect score. The average was really good though, so you can submit them multiple times. The highest grade is the one that is going to go to Skyward. Use this time now to start on homework 3. So 1 and 2 you should have finished. Now we're working on homework 3. Our test is next week on Tuesday.